Okay, so we are up to question 7b of exercise 14h, which is asking us to solve the following equation for theta is equivalent to 0 to 2 pi. And as you can see here, we're given cos of 2 theta equals the square root of 3 over 2. The very first thing that we should notice when doing this question is the fact that our period is going to be different because of this 2, and we really don't want that to be the case. So to fix this situation, what we're going to do is I'm going to say, all right, let x equal 2 theta. And by doing that, I can now rewrite this equation as cos of x. That's the most disgusting looking x I've ever seen in my life. Let me try again. Cos of x equals the square root of 3 over 2. Now that I have it in terms of x, I also need my domain in terms of x, but currently is in terms of theta. So I'm going to have to do something to change that. The first thing I'm going to realize is that if theta is equivalent to 0 to 2 pi, well, that means that if I had 2 theta, that would mean that I would double my domain. So the double of 0 is 0, and the double of 2 pi is 4 pi. So if theta is equivalent to 0 to 2 pi, then 2 theta is equivalent to 0 to 4 pi. And we know what 2 theta is because over here we defined 2 theta as equaling to x. So over here I could say, well, that means that my x, there's another disgusting x, that means my x is going to be equivalent to 0 to 4 pi. And that's really all the background information we need to do. We can now work from this in order to solve my question. So we come over to our unit circle and we go, all right, we know that we're dealing with cos. So if I'm dealing with cos, that means I'm looking at my x-axis and I'm saying, all right, where on my x-axis do I have the square root of 3 over 2? And I know where that exists. That exists over here. So it's my biggest number, the square root of 3 over 2. So I can do a little something up to there. You know what? I'm actually going to change that a bit because I think it should be a little further over to the right. So if you can just give me a second as I change it, I think it should actually be here. Of course, this isn't to scale, it's just me being pedantic. So let's just say that's there. And I'm also going to have it here as well. So these are going to be the 2 places on my unit circle in which I'm going to get my x value being the square root of 3 over 2. And I could actually write out my coordinates for each one. So one will be the square root of 3 over 2, and my y value will be 1/2. And then down here, I'm going to have the square root of 3 over 2, and my y value will be -1/2. Perfect. And now that I've done that, I can get rid of this. And what I'm going to do now is put in my lines, which is going to help me figure out what my angle is going to be. So I'm going to have a line from here to here, and another line from here to here. Perfect. Now, this is where memorizing your unit circle becomes ever so important because you're going to have to memorize what this is. And hopefully you know immediately that this is going to be pi on 6. It's going to be pi on 6. So I'm going to start over here. I'm going to write x equals, and my first answer is going to be pi on 6. So what this is telling me that is when cos is pi on 6, it's going to equal the square root of 3 on 2. The other place where I'm going to get an answer will be, as you can see, if I go right around over here, this long angle here. And this will be, as I've memorized my unit circle, will be 11 pi on 6. 11 pi on 6. So I can come over here and write in 11 pi on 6. Now, you might think we're done, but we're not, because we have gone around our circle once and found 2 values of x. We've gone around 2 pi times. But if you look at our domain is from 0 to 4 pi. So that means we need to go around our circle again to find 2 more values of x. So what it's going to look like is I'm going to go around my circle once, and that will be 2 pi, and then I'm going to go a bit more, and this will be pi on 6. So the way I like to think about it is I'm taking pi on 6, and I'm going forward 2 pi. That's an ugly looking pi. So I can do my working down here. I have pi on 6, and I'm plussing 2 pi to it. I'm going to have to times the denominator by 6. I'm going to have to times the numerator by 6 to get me 12. So it's going to be 13 pi on 6. So that means my value up here is going to be 13 pi on 6. Next, I'm going to have to figure out what my next one will be. So I'm going to go around some more, around until I get to this. So it's going to be 2 pi plus 11 pi on 6. So in other words, what I'm doing is I'm taking 11 pi on 6 and I'm plussing, oh, that's not the color I wanted. I wanted black. I'm taking that and I'm going forward 2 pi, forward 2 pi. So I'm taking 11 pi on 6 and I'm plussing 12 pi on 6, which is going to give me 23 pi on 6. Perfect. Now I'm going to write in that answer. So it's going to be 23 pi on 6. Nice. And there are my 4 solutions for x, having gone around my unit circle twice. Now what I'm going to do is I'm just going to do some cleanup. I'm just going to get rid of this. I'm going to get rid of this and this and this. I don't need any of that. All right. Now, as you see, my values are in terms of x, but if you look up here in my question's in terms of theta. So what I want to do is I want to change this so it's in terms of theta. So I'm going back to theta. So how are we going to do that? Well, let's first realize if I was to copy this and bring it down, this is x equals all these values, and we know what x equals. We know that x equals 2 theta. So I could get rid of this x, and I could put 2 theta in its spot, 2 theta. Having done that, I now need to get rid of this 2, so I just have theta by itself. And the way I'm going to do that is by timesing everything by a half. So by timesing this side by a half, I'm going to get rid of those 2's. I'm going to times this by a half, I'm going to times this by a half, and I'm going to times this by a half, and I'm going to times this by a half. So I'm going to end up with theta equals, I'm going to times these denominators together to get pi on 12. I'm going to times these denominators together to get 11 pi on 12. Then I'm going to get 13 pi on 12. And lastly, I'm going to get 23 pi on 12. And as you see here, I have just answered the question. And now it's in terms of theta, all is right in the world. And there you go. There's your answers to this question. Hopefully this has been helpful to you. If you've got any questions, feel free to ask me in class or any time that's convenient for you.